7.4, approximating square roots. Rational number. A rational number is a number that can be written as a ratio, apparently can't read my own handwriting, of two integers. Real numbers. Rational numbers and irrational numbers together form the set of real numbers. Irrational number. A irrational number cannot be written as the ratio of two integers. The square root of any whole number that is not a perfect square is irrational. The cube root of any integer that is not a perfect cube is irrational. The decimal form of any irrational number neither terminates nor repeats. So when it says it doesn't terminate, that means it doesn't end. So we have real numbers, which branch off into rational and irrational. Anything involving pi is irrational. Any non-perfect cube is irrational. Any non-perfect square is irrational. Rational numbers, that includes terminating decimals like 2.25. Repeating decimals like this right here says 3/10 repeating. 2/3 is a fraction, the number 1/2, any positive or negative whole number. Next subset is an integer. The integers are positive and negative whole numbers. A whole number is any number 0 and above that are whole. And then natural numbers, those are your counting numbers, 1 and above. So 1 to infinity, all whole numbers. So we're going to classify some real numbers. So the subset of the square root of 12 that is irrational. The reasoning, 12 is not a perfect square. $2,500 is repeating. This is a repeating decimal. That means that it is rational. 2,500 repeating is a repeating decimal. The negative square root of 9, well, this is going to give you an answer of -3. So this is not only rational, it is also an integer. So you want to put all the subsets. So in parentheses, it could be multiple. And this is because the negative square root of 9 is equal to -3. 72 divided by 4, that is going to be rational because it's a fraction. 72 divided by 4 equals 18. Well, 18 is an integer. It is also a whole number. And lastly, it's a natural number. So if you're getting confused with whole and natural, whole is positive and negative. Whole numbers are all positive numbers including 0. Natural, you do not include the 0. The reasoning, 72 divided by 4 is equal to 18. Pi, this is irrational. Reasoning, the decimal form of pi neither terminates nor repeats. So go ahead and classify the next 3. F is irrational. That number does not repeat. Letter G is rational and also an integer. And letter H, you should have had that as irrational. The cube root of 2 is not a perfect cube. All right, number 2, approximating a square root. We're going to estimate the square root of 71 to the nearest first integer and then to the nearest tenth. So make a table of numbers whose squares are closest to 71. So I chose the numbers 7, 8, 9, 10. The square of 7 is 49, 8 is 64, 9 is 81, and 10 is 100. So the square root of 71 is between 64 and 81, but because 71 is closer to 64, the square root of 71 is approximately 8. So if we were to be rounding that, we would say it's approximately 8 for the square root of 71. Not exactly. So now we're rounding the nearest tenth. So for 8, I chose 8 and 3/10, 8 and 4/10, 8 and 5/10, 8 and 6/10. It had to, I did a little guess and check. You can also do that before you make your table. This is 68 and 89 hundredths. We have 70 and 56 hundredths, 72 and 25 hundredths, 73 and 96 hundredths. So 71 is close, or is between 8 and 4/10 and 8 and 5/10. However, it is closer to 70 and 56 hundredths. So because the square root of 71 is closer to 70 and 56 hundredths than 72 and 25 hundredths, square root of 71 is closer to 8 and 4/10. All right, we're gonna compare real numbers. Which is greater, the square root of 5 or 2 and 2/3? Let's start by estimating. Square root of 5, 2, the nearest integer. 1 squared is 1, 2 is 4, 3 is 9, 4 is 16. Square root of 5, it's going to be between 4 and 9, so it's closer to 2. So the square root of 5 is approximately 2. So I'm going to make my number line. Here's 1, I'm going to skip 2, I'm going to skip 2, I'm going to skip 2. There we go. Okay, number 2. We're then going to graph the numbers on a number line to compare. So the square root of 5 is closer to 2. So I'm going to say the square root of 5 is over here. And then 2 and 2/3, that's why I broke this up to where it has 2 lines in between each of these, because this right here is 2 and 2/3. 2 and 2/3 is greater than the square root of 5. And then I have my work to support that with that graph. All right, example 4, approximating the value of an expression. The radius of a circle with area A is approximately the square root of A divided by 3. The area of the circular mouse pad is 51 square inches. Estimate the radius to the nearest integer. Well, the square root of the area divided by 3, we know the area is 51. So it's 51 divided by 3, which is the square root of 17. 17 is very close to 16, so we're going to say it's going to be approximately, and I should put the approximate sign as well here. It's the 2 squiggle lined equal signs. It's approximately 4 inches. And I misspoke. We have one more. Example 5, real life application. The distance in nautical miles you can see with a periscope is 1 and 17/100 square root of h, where h is the height of the periscope above the water. Can you see can you see twice as far with the periscope that is 6 feet above the water than the periscope that is 3 feet above the water? Well, let's try this. 1 and 17/100 times the square root of h, 1 and 17/100 times the square root of h. One of these we're going to replace with 6, and the other one we're going to replace with 3 for the H. So this one is approximately 2. This one is approximately 2 9/10. So to actually get from, oop, I think I misspoke. This one is 2 9/10. This one is 2. So to get from here to here, that's approximately multiplying 1 45/100. So the way I did that is I did 2 9/10 divided by 2. So to answer the question, no. You can only see approximately 1 45/100 times as far with the periscope. That is 6 feet, oops, above the water. All right, great job. Go work on big ideas.